I'm to talk to you about version control with Mercurial. What I want to do is I want to motivate why this is interesting. We are sort of now moving on to the developer-centric portion of the workshop. Or not, well, not centric, but certainly focused more on development, internals, how to get your hands dirty, how to share code, how to distribute, and so on. This is, I guess the first part was building a base level of experience, and now we want to move on and start trying to figure out how we can expand the community and sort of collaborate effectively between people. Because what this is, the whole thing is based on this idea of collaboration and building community between users and direct technology transfer between astrophysicists. So I want to talk about the main mechanism that we use for doing such a thing. So basically what the motivation here is that our code changes with time. There is a given version of a code at a certain time, and then people come along and they add on widgets and so on and so forth. And usually what has happened in years past is that this would be manifested in a tarball on a website that someone would update every once in a while, or maybe FTP into wustel.woarchive.edu or something, and you would download the newest tarball. But really what we want to do is we want to be able to track changes in some sort of centralized, or track changes in some sort of rigorous way. Be able to see what changes between versions, how things go. If something bad is introduced into the code, when was it introduced, how was it introduced, and motivate changes between time. And as a secondary point to that, what we want to be able to do is we want to be able to distribute changes. This idea of just distributing things in terms of tarballs or archives or individual flat files, and let me send you the update to that file, isn't really scalable. It doesn't work over time, and it doesn't really present an opportunity for easing distribution of code and changes. And so what we want to do is we want to introduce this idea of controlling our versions. What I mean when I say version control is I mean some mechanism of watching versions of the code evolve. And that doesn't necessarily mean, this is version 1.1, this is version 1.5. It really means, this is a particular time in that evolution of the code, and some people may have run run analysis with it, or they may have run a simulation with it, and then it has evolved incrementally over time. Now there was this old model for a very long time called centralized version control. This would, I'll talk a little bit about some of the version control systems there. And what this really meant is it meant that there was some cloister of anointed users that had access to some pristine code repo. And if you were a member of that cloister of users, you were able to make changes to that pristine code repo. A particular place that you were able to store everything, and it was canonical, and you had to have permission. It was, all this stuff gets built up over time. There was a single authoritative location with a single, essentially linear history, right? If I'm working on something and John's working on something, those changes are committed sequentially to this repository. In the old days, this would have been something like RCS, which is one of the very first mechanisms of systematically controlling changes, which was then turned into CVS in a sense. CVS is a front end onto this basic system of RCS. And then ultimately this became Subversion in about the year 2000. Over time, this idea of distributing version control became much more prevalent. Possibly, as laptop batteries increased, people would start working on flights, so they wanted to be able to commit. This is the classic problem, is this idea of the airplane problem. I'm on an airplane and I want to be able to commit a change to my code, but if I don't have access to that anointed cloistered code repository, I can't necessarily do that. Since Wi-Fi isn't really on airplanes, that becomes a problem. And so there's this notion of a distributed version control system. And in this system, everything is changed. And the one we're going to talk about is Mercurial, or HG. You can get it, Mercury. There we go. Which was started in about 2005, essentially concurrently with Git, both to provide a solution to this problem of the BitKeeper problem on the Linux kernel source. But there are also other ones, such as Bazaar, which is the code that Galacticus uses, that Ubuntu uses on Launchpad, and then two prototype codes called Monotone and Darks. Monotone is actually the one that largely informed both Mercurial and Git in 2005. And darks is a much more complex code that is difficult to scale with large code bases. Now, all of these distributed version control systems have a concept of something called a DAG. A DAG is a directed acyclic graph. So what that means is you've got a graph, all these different nodes, and then they always flow downward. Everything flows downward. One node never connects to one of its parents. Okay? So you can think about this, let's say that Sam and I both start with a version of the code. Sam commits something and I commit something, but I can never go back in time and become, I can never go back at that point and then influence the initial version. So essentially it means you can't become your own grandfather. There's this concept, and I'll show a diagram of that in just a moment, but each node in this directed acyclic graph is a change set. So what we're doing is we're building up a vocabulary here of fixed locations in code and relationships between those locations. Just as a quick side note, with Mercurial, numbers are local and the hashes are global. That'll become important in just a moment. And a head is a change set with no children. So now let's see what that, oh geez. Well, my image didn't really come out, but what I can do is I can actually show you what something like this looks like. So this is what the YT DAG looks like. See up here at the top, Sam Skillman merged. And this is a change set. So this particular location in the code is a change set. It has two parents, one of them way down here, and one of them right here. This is a head because it has no children. This is not a head because it has one child. And you can see that what's happening is everything flows upward. And now I'll continue to scroll down. Sorry? So here's the change set. And you can see if I hover over it that it's 2A62FB4AC. It's a hash. Now it has one parent and another parent. Now this guy right here is a merge. He has this parent and this parent. You can see each one of these is an individual change set. And there's this graph of the way that the code changes over time. Now it looks relatively complex because there's a whole bunch of merging and so on going on. Now one reason for that is if you take a look, let's say right here, Nathan and Sam were both independently developing. So they both created their own change sets, and each one of them was then a head. And so Sam then merged them together. It's not as complex as it sounds. Let me go back to the presentation. Now the question is, why do we use Mercurial? Up until 2009, we just used Subversion, and before that, actually, we used CVS for a little while. And we moved to Mercurial in about January of 2009. We host our repositories on Bitbucket, and we have a number of reasons for using it. The first off is that Enzo uses it. Enzo moved to it full time, and a number of the YT developers are also Enzo developers. It has immutable history, and this is a big deal. We don't rewrite history with Mercurial. Once you commit a change set, that's it. It's in there. And so that means that that SHA will remain forever. And what you can do is you can go back and identify the individual change set that you used to run a given piece of analysis. It has a nice and easy API. It's relatively easy to learn. It only has a couple dependencies, and it's built on Python. It's very easy to get and comes with YT. All right, so moving on. A repository is a complete history of the changes in a project. So here, so YT uses HG and it comes with the installation. So I want you all to do this. So cd to your YT dest directory. This is where you've installed YT. And I want you to just type HG log. How far back does it go? First person to win. First person to answer gets a. That's right, 2007. And so that's, I didn't even have to say the prize. So that is the very first change set, and it's actually in your repository right now. If you wanted, you could update to that initial proto version of YT. It will be completely non-functional, so I would recommend you not do so. But that's totally local. It doesn't have to touch any other server. Everything is stored within that single repository. Now try the second one. want to read the log? Just what, I mean, does it say something? What day is it? Okay. So yeah, we can step through the entire history of the repository. Now there's a side effect of that. What we can do is we can annotate, for instance, and I'll show you all of these commands later, but we can do hglog on a given file. And what it does is it tells you all of the times at which that file was changed. Now I've just done the log on the credits file. I know this is a little bit small. How's that? Is that more readable? And you can see the credits file has changed in 2008, 2009, 2010, 2011. And if you look, you can even see that on Thursday, August 4th, we added Eve and JC to the credits list. So we have the entirety of the repository locally. Now, that gives us another couple things, like we can see when things have changed, and on and on. But let's get back to this whole idea of Mercurial. So what I want everybody to do, if you haven't already done this, oh, and this is geez, another typo. What I want you to do is I want you to run the command yt bootstrap _dev, and I will fix this on the website. Bootstrap _dev. And what that'll do is it'll set up your Mercurial username. So what it means is it'll ask you what's your first name, what's your last name, what's your email address. Underscore. And it'll set up a couple Mercurial extensions that we use to develop things. Now you might ask, why do you need an HG username? Well, it's because there's no centralized authority. So what happens is you sign every single one of your commits with whatever you put in your username as. You don't have to get a username if you don't want to. So don't feel obliged. Yes, it is. Is it possible to sign commits with, I guess, GPG or PGP keys? It is possible. What it does is it actually tacks on a second sidecar self-signed commit. You should not feel obligated to do this because it will create a secondary username, but you can also say no when it asks you to. The most important is this first item, and it will tell you when it has completed that. At that point, you may Control-C out. Okay, did everybody has an HG username? You filled in your name and your email address. That's only stored locally. You don't have to worry about anything else. If you then Control-C'd out before the bitbucket.org user creation, that's all you need. It's only stored locally and it doesn't touch any external server. So let's try this together. Go to some temporary directory and make a new directory called, I don't know, I called it here new _ repo for new repository. Then cd into that directory. Oh, my output stripped off something. Echo hi there into the file readme. My syntax highlighting stripped that off. And I will go ahead and I will do that with you. mkdir new repo, cd new repo, echo hi everyone at home into readme. HG init, which initializes a Mercurial repository, and then add readme to it. So what you've got is you've got an empty bucket, and now we're adding to it readme. Now we commit. You give it a little message, and then you can type hglog, and you can see that it's there. Now I'm going to change back to the slide so that people can see the shell commands. Is anybody having any major problems? Oh. Yes. Here, do this. Export, editor. Oh. You can do something like export editor equals nano. Nano's a little bit friendlier. And then echo something else into README. And now the README file has changed. So when we do commit, it will then commit a different version of the README file. A new version of the README file. How do I quit out of... And now when we do hglog, you can see there are two changes. The initial repository, and then a new one. Did everybody manage to make 2 commits? Okay. Well, we'll wait just a second. Yeah, you can edit the README file, or you can make a new file and add that. But you just, so the idea is that if you make changes to any file that Mercurial already knows about, then you can make a new commit. So in this case, no, that's right, you don't have to add the README again. I'm going to put them up there. They're in the slides. So if you look on the slide, you'll note that I did this -m first commit. That just means that's the commit message. Don't prompt me for a different one. If you don't supply a -m and then the commit message, it'll prompt you for a new one. So does everybody has at least 2 commits? Anything. All right, so now we can cat README. You can see that it's something else. But now what we can do is we can also update to the original hash. It tells you that a couple files have been updated, 0 files merged, whatever. And now when we cat the README, you can see that it's the original version of it. Right? Okay. So the idea here is that we control all of the different versions of our code, and we can inspect it at any different time. And in fact, here's my version of YT. What I can do is I can actually update to something like YT 2.0. And what it'll do is it goes out and modifies all the different files inside my directory in order to match the state of the code at exactly that time, and I can now examine it. So the point that I kind of wanted to get across here is that you don't have to talk to any external server to make a new repository. You can update to any time in the code. The commands are relatively straightforward, and you can inspect changes over time. Now there are a couple other commands Init we already talked about. Add we already talked about. RM. We're going to remove a file from tracking. So what does that mean? So here, I will go back to our temporary little repository. I update to the current state of the code, and you can see README still says something else, right? So now what I'm going to do is I'm going to HGRM README, because we decide that we don't need a README file anymore. Right? Nobody needs a README file these days. And now I commit. Removing README file. It seems unnecessary. The code is self-describing. Okay, so now you can see we now have 3 revisions. This one has no README file. So what do we do when we file that? We get it from non-current files. Yes, update to release version. So you can -r and the version hash. Now what do we get the README file? That's right. So now what happens if we modify the README file? That's right. Now I have 2 heads. So I set it sort of something else entirely. I commit, making a new README modification. And it's created a new head, right? So now I look at the log. You can see the order. But look, the top head is the parent, and this head is also the parent. So now we pull up our HG serve. I'll show you. Now you can see I've made a modification that internal ago. 5 seconds ago, versus the README file. 8 seconds ago, making the README modification. 100 seconds ago, remove the README file. So this is the graph. So we have the urgent string development. Okay. Sure. Sure, sorry. That's right. 2 strings is implicitly 1 or. Unless it skips, it doesn't. That's right. It skips this idea. Okay. Now I don't want to do this too much. There are a number of materials out there that will clear about 9 actually describing this in detail. But there are a couple of pretty important commands. There's commit, which we've already seen, update, which we've already seen, and then serve, which we've already seen. Serve actually really built in. It allows you to store the graph, look at the save files, time, you know, different things. It also allows, for instance, to serve a web repository, needs to serve a repository, and I can change the repository without talking to each number. So push, pull, merge are important ones. So now I don't know if you know this, but when I was over here in my watch source the HG repository, you can see that you can see the last time I did April 15th, 2011. That is a Mercurial repository. It has really 9 months now. What you do, you pull data sets from the server, right? So remember, each set of individual objects. They're defined by a div, a parent, it can host 2 parents. Okay? So they're defined by a 2 parents. So what the HG pull command does is it goes to the server and says, what's the most reading order all data that you have in each one is its own distinct object. And it says, if I give me everything you have in now can there be what's going on with HG coming? What's going on with the server? Anything we have for me? Let's say actually doing a tree merger with respect to the graph. You don't have a, it will work unless there's a default graph. I'll just run my primary browser. So you need a whole bunch of changes that go that time. The most simple are the ones that are maintenance. So that's what you output HTTP is. So you guys specify back to a repository. You can also do something like HTTP.org. HTTP analysis. It'll allow you to do the same thing. But you can also do things like HTTP incoming SSH, some host, /path to repo. It'll do it. But we really want to pull all the unit tests. Right? We want to say everything you got to go. And so you do HTTP pull. And it doesn't change your current working record. The HTTP pull operation will not change anything you're doing. All it does is it can do opportunities into the set. Now you can update to tip. And you can see now, yes, I now have the most recent version. The opposite of this command is upload and push. There are no upload change sets. I have committed anything. I'll say I'm off the README and I say, this is being done at the workshop. And you know upload README. Now you go going. I got internet control better. You can see I haven't changed that. So I'm going to say push. That's what we're going to send. So let's put and push it to the repository on this. It isn't funny fucking thing. Okay. Merge is one reason I want the SSH is you want the number that merge convert development. Then I'm sure you can go ahead and find a new head, but I can update to the state of code in 2010 and I make it and that change something I go. I guess I didn't look at them. So this is basically these are the basics of Mercurial. What I really want to get across here is that at no time in our development or repository do we have to do anything special. All we have to do is load our machine. We push around with SSH, we push it to the record computer, and we push it to people at comments. This is powerful. Anyways, I'm going to show how to use it with typically how to use it with and there's some great tools and that's out there by people. Thank you very much. Questions or anything?